How do I clone a list so that it doesn't change unexpectedly after assignment? While using new_list equals my_list, any modifications to new_list changes my_list every time. Why is this, and how can I clone or copy the list to prevent it?
New_list equals my_list doesn't actually create a second list. The assignment just copies the reference to the list, not the actual list, so both new_list and my_list refer to the same list after the assignment. To actually copy the list, you have several options. You can use the built-in list.copy method, available since Python 3.3. You can slice it. Alex Martelli's opinion, at least back in 2007, about this is, that it is a weird syntax and it does not make sense to use it ever. Smile, in his opinion, the next one is more readable. You can use the built-in list constructor. You can use generic copy.copy. This is a little slower than list because it has to find out the data type of old_list first. If you need to copy the elements of the list as well, use generic copy.dcopy. Obviously the slowest and most memory needing method, but sometimes unavoidable. This operates recursively, it will handle any number of levels of nested lists, or other containers. Example. Result.
Felix already provided an excellent answer, but I thought I'd do a speed comparison of the various methods. So the fastest is list slicing. But be aware that copy.copy, list column, and list, unlike copy.copy and the Python version, don't copy any lists, dictionaries and class instances in the list, so if the originals change, they will change in the copied list too and vice versa. Here's the script if anyone's interested or wants to raise any issues.
I've been told that Python 3.3 Plus adds the list.copy method, which should be as fast as slicing.
What are the options to clone or copy a list in Python? In Python 3, a shallow copy can be made with. In Python 2 and 3, you can get a shallow copy with a full slice of the original. Explanation. There are two semantic ways to copy a list. A shallow copy creates a new list of the same objects. A deep copy creates a new list containing new equivalent objects. Shallow list copy. A shallow copy only copies the list itself, which is a container of references to the objects in the list. If the objects contained themselves are mutable and one is changed, the change will be reflected in both lists. There are different ways to do this in Python 2 and 3. The Python 2 ways will also work in Python 3. Python 2. In Python 2, the idiomatic way of making a shallow copy of a list is with a complete slice of the original. You can also accomplish the same thing by passing the list through the list constructor. But using the constructor is less efficient. Python 3. In Python 3, lists get the list.copy method. In Python 3.5. Making another pointer does not make a copy. Using new_list equals my_list then modifies new_list every time my_list changes. Why is this? My_list is just a name that points to the actual list in memory. When you say new_list equals my_list, you're not making a copy, you're just adding another name that points at that original list in memory. We can have similar issues when we make copies of lists. The list is just an array of pointers to the contents, so a shallow copy just copies the pointers, and so you have two different lists, but they have the same contents. To make copies of the contents, you need a deep copy. Deep copies. To make a deep copy of a list, in Python 2 or 3, use deep copy in the copy module. To demonstrate how this allows us to make new sublists. And so we see that the deep copied list is an entirely different list from the original. You could roll your own function, but don't. You're likely to create bugs you otherwise wouldn't have by using the standard library's deep copy function. Don't use eval. You may see this used as a way to deep copy, but don't do it. It's dangerous, particularly if you're evaluating something from a source you don't trust. It's not reliable if a sub-element you're copying doesn't have a representation that can be evaled to reproduce an equivalent element. It's also less performant. In 64-bit Python 2.7, on 64-bit Python 3.5,
If you want to see more, please consider subscribing.